Hello, my name is Keshwani. It's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for the GRE. We have been solving GRE math problems out of this book here, the official guide to the GRE, the revised general test. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 228, and today is our lesson number 104. Please turn to page 228. The very first problem that you see there, it has to do with inequality 2.5.1. Now here's the deal. You have to have the book in front of you, otherwise you will not follow me. Okay, this is enough of the geeky thing. I'm going to undo it. Enough of the geeky look, as I said. Here's the deal. If you do not have the book in front of you, you're not going to follow the work. Turn to the page 228. Look at problem number 2.5.1, and you will see that the problem as I presented on the blackboard has been modified. This is what the problem reads. It says, which of the following could be the graph of all the values that satisfy the inequality that we are about to solve. And this problem, the way it's presented here in the new format, is the same problem that you will find on page number 157. And the answer choices that pertains to this particular problem are the ones that you will find on page 157. In addition to this problem, if you want to solve a couple of more problems for practice, you can watch day number 59 and day number 60, and you will see two more problems that I solve that pertains to the question number 8 on page number 157. So the answer choices here, it says here, see page 157 for the answer choices. Those are the answer choices, exact same answer choices, no change in them, are the ones that pertain here. One more time, I'm going to read the question to you, and this comes straight from page number 157. It says, which of the following could be the graph of all values of x that satisfy the inequality? And the inequality is negative 3x plus 5 is less than or equal to 17. So we're going to solve this inequality. Solving inequality is no different than solving equality. All the rules that apply in solving equality apply to inequality, with one or two exceptions. We'll come to when we get to them. We'll discuss them. Okay? Or as Kramer will tell you, we'll jump that bridge when we get to it. For those of you who do not know who Kramer is and what I'm talking about, don't worry about it. It's from a character from Seinfeld. We'll cross that bridge when we get to it. He says we'll jump that bridge when we get to it. Okay? So here's the thing, here's the inequality. Very first thing we need to do is subtract 5 from both sides. So that we can get rid of this 5 here. So now we have positive 5 and negative 5 here. It drops out. And here we have 17 minus 5, we get a 12. 12 is less than or equal to, and this minus 3x comes down. Now we have to somehow get rid of this minus 3 from that side. We need to divide both sides by negative 3. We need to divide both sides by negative 3. And this is where the things get prickly. This is where things get prickly. This is the exception that I was talking about. For example, would you agree that 3 is less than 4? Of course 3 is less than 4. What if I were to multiply both sides by 2? Would you still agree that 2 times 3 is less than 4? Or 2 times 3 is less than 4 times 2? Of course, 2 times 3 is less than 4 times 2. But what if we were to multiply both sides not by 2, but by negative 2? If we were to multiply by negative 2. If we multiply both sides by negative 2, the negative 2 times 3 is negative 6, and negative 2 times 4 is negative 8, and now this is no longer true. Negative 6 is not less than negative 8. Negative 6 is in fact greater than negative 8. So what did we learn here? What we learned is that if you multiply both sides of the inequality by a negative number, or if you divide both sides of the inequality by a negative number, the inequality, direction of the inequality switches. For example, let's do the division. For example, 10 divided by 2, 10 is less than 12. Of course 10 is less than 12. Now if I were to divide both sides by 2, this thing still holds. 10 divided by 2 is 5, and 5 is less than 6. It still holds. But instead of 2, if you were to divide both sides by negative 2, then 10 divided by negative 2 is negative 5, which is no longer less than negative 6. This is no longer true. We have to switch the direction. So as soon as we divide both sides by negative, the direction changes. The direction of the inequality switches if you were to divide both sides of the inequality by a negative number, or if you were to multiply both sides by a positive number. Let's make a note here. Where should we put it? If we multiply or divide an inequality by a negative number, the direction of the inequality switches. You have to just know that part. Direction of the inequality switches. I was putting way down there because I need the room here to put the answer choices. So I'm going to have to squeeze the answer choices there. So that's why I did not simply divide there, because that sign is there. So now we just divided both sides of the inequality by negative 3. So this is no longer less than or equal to, this is greater than or equal to. The direction of the inequality switches. And now we can cross out this negative 3 that you see there with this negative 3, it goes away. And we get x is greater than or equal to 12 divided by negative 3, which is negative 4. And that's our answer. X is greater than or equal to negative 4. We have to show this on the graph. And the 5 answer choices that are presented to you on page number 157. I want you to turn to page number 157 so that you can see the answer choices. And the 5 answer choices that are presented to you are like something like this. I need a little bit room here, so I need to erase this part. I'm going to try to squeeze all 5 of them here. 1, 2, 3, 4, 5. Here's your 0. That's your 0 for the 5 answer choices. Turn to page number 157, as I said already many times, and you will see the answer choices there. And then you have those are your A, B, C, D and E. Okay, I'm going to put the 5 answer choices now. A looks like this. It starts with some positive quantity. It starts with a positive quantity and goes all the way. This is your A. B starts in a negative range and goes all the way there. In the C, it starts with some positive quantity and goes all the way there. D is between some positive quantity and some negative quantity. And finally, E is some negative quantity, negative range, and some of it in positive range. Which of these 5 will apply here? Which of these 5 will apply here? Well, X is greater than or equal to negative 4. X is greater than or equal to negative 4, which means X starts out in a negative territory at negative 4. This is your 0, 1, 2, 3, 4. Here's your negative 4. X starts out here, but then it is greater than or equal to. So it starts out in negative territory and goes all the way there. It starts out in negative territory, goes all the way there. That's this one right here. This is our answer. Answer is B for this problem. That's all. That's it. We're done. I'll see you tomorrow when we'll do the one problem that you see right underneath it. I could squeeze in both of them in the same video, but that gets to be too long, so we'll just do one at a time. But anyway, this was it. Again, one more time, what you have to remember is, I'm going to read it one more time in the event that you have trouble reading my handwriting. It says, if we multiply or divide if we multiply or divide an inequality by a negative number, like we did here, we divided by a negative number, the direction of the inequality switches. Before it says less than or equal to, it became greater than or equal to. That's all. That's the part people sometimes miss, and they muck it up. Muck it up. Muck with the M. Alright, don't get excited. Not F. Never. I'll see you tomorrow, okay? Bye.